The distributive property part 1. Now, if you've watched the distributive bags lesson, then this just continues on from there. If you haven't, I'll sort of teach this like you haven't seen that part as well, so you get the whole thing here. So when do we use the distributive property? Distributive property is used when we encounter the situation where we are multiplying a constant by a polynomial. We could use repeated addition to simplify or expand the expression, but we're not going to do that once we get the shortcut down. So one more time, just like in the distributive bags lesson, we'll show you the whole thing. For instance, if you were multiplying 2x plus 5 by 3, you could just add 2x plus 5 3 times. So right here, let me get my pencil already here. Right here, it says 3 times 2x plus 5, so it goes, okay, 1 2x plus 5 plus another 2x plus 5 plus another 2x plus 5. You can imagine how much trouble this would be if that was like a 20 out front or like a 70 out front. But we'll just do it here to get used to the numbers. So what you get from those terms is a 2x from the first term. Maybe I'll use my highlighter there. I'll get in there and go, okay, well, there's a 2x in the first term and a 2x in the second bracket, and there's a 2x in the third bracket. And then there they are there, 2x and 2x and 2x. And then there's a 5 and a 5 and a 5. And what we're doing is just collecting like terms from each set of brackets. And what I get here is 6x plus 15. But is there a shortcut? And yes, there is. We won't have to write this out every time, because we certainly don't want to have to write this out every time when the number gets big. The answer is yes. If we multiply the 3 by each term inside the brackets, we can skip the steps in between. That is called the distributive property. Let me go back and show you what I mean. We could have right at the start went, okay, 3 times 2x gives the 6x. 3 times 5 gives the 15. That's the distributive property in a nutshell. If you've got something out in front of a bracket, you just multiply it by each term that's being added inside the bracket. Or subtracted. It works for subtraction too. So some examples just to get the idea. Well, lots of examples. 6 big examples here to get the idea. So instead of writing this out, we're just going to take the number out front and multiply it by the first term. And I get 35x. And I multiply it by the second term. And 5 times adding 2 is adding 10. Or 5 times plus 2 is plus 10. You know, either way you want to say that. That's it. That's the distributive property. I mean, the rest is just details, special situations. So here we are again. There's a number in front of the brackets, and so you multiply it by each term. And I really encourage you to draw these arrows every time to remind yourself to multiply that 9 by each term in the bracket. So here I get 36x. And then 9 times 7 is 63. That's it. It's called expanding the brackets because, well, the reason it's called expanding is because of what happens out here. See how it expands out into multiple brackets? We're sort of skipping that step. So expanding is a weird name for it here because it doesn't really seem to be expanding at all. But we're sort of skipping all the math in between there where there's an expansion that happens. Okay, let's try out some more special cases. This time there's a negative out front. That's not a big problem. Negative 3 times 2x is negative 6x. And then negative 3 times 1 is negative 3. If you have trouble remembering to multiply both things, I encourage you to draw the arrows and write the terms as you go. What I mean by that is go, okay, draw the arrow for the first one, negative 4 times 15x, that's negative 60x. Then draw the arrow for the second one. And this one's a little weird in that it's negative 4 times subtract 8, which confuses people. So you can think of it this way. It's like negative 4 times negative 8. And negative 4 times negative 8 is positive 32. So what I'm doing is adding 32. And it might seem like I'm playing a little loose with the rules there, but it totally works. You can think of that symbol right there as negative or subtract, whichever you need to think through the question, and it totally works. For instance, in this question, when you first read it, it's like 15x minus 8. It looks like a subtract sign. Then when I go to multiply it, I think of it as negative 8, negative 4 times negative 8, which is positive 32, which I think of as add 32. And that's totally legitimate. All those moves are totally legitimate. That totally works. So the difference between negative and subtract is this symbol here, a negative or subtract? And the answer is it really depends on how you're thinking about it. So you sort of get your choice here for whatever's easier to think about. Okay, keep going with special cases here. This special case has 3 terms in there. Well, that doesn't really change the game all that much. You multiply negative 12 times the first one, and I get negative 48x squared. You multiply negative 12 times the second one. Okay, negative 12 times negative 3, that's positive, so I'm going to write adding 36x. And then negative 12 times negative 9 is positive 108. You see, having extra terms in there really doesn't change the game all that much with distributive property. You just have to multiply it by more terms, that's all. Okay, now I'm going to act like this one's no big deal, even if as you see it, you might think it is a big deal, and then I'll come back to it in a second. So, out front is an x, so x times x, oh, that's x squared, and x times 2 is 2x. I acted like that was no big deal, but I really actually changed the examples there. Before that, it was always just a number out front, and this time it's a variable out front, and actually the distributive property works for those as well. You just take whatever is out front and multiply it by each thing in the bracket. So that takes a little more thinking. X multiplied by x, we add the exponents and we get x squared. X multiplied by 2, well, you can think of that as like, it's like just like 2 multiplied by x, so that's 2x. So that's where both those terms came from. Okay, so I just slid that example in there to sort of expand us out into the situation where there's a variable out front. So, and I'm going to address that here. Notice the last example slips in a variable out front. That situation we need to be able to handle as well. To get ready for that, let's do a quick review of multiplying monomials. So multiplying monomials can be a little bit tricky, and so I'm going to go over that whole example again on how to multiply monomials, just in case you found it a little tricky beforehand. Say you get in a situation where you're going 5x squared times 3x to the power 6. At first glance, this looks like a little bit of trouble because it's a big mess. But here's an important sentence. Here comes my highlighter. Multiplication is both commutative and associative. Whoa, fancy words. And what do those fancy words mean? Well, I'm going to highlight this sentence too. Essentially, it means that if multiplication is the only operation involved, we can do the multiplication in any order we wish. A simple example of that is, if you do 3 times 4 times 5, you'll get the same answer as if you go 3 times 5 times 4. And you get the same answer as if you go 4 times 3 times 5. Or you get the same answer as 5 times 3 times 4. See, it doesn't matter which way you do multiplication if it's only multiplication that's involved. So in this multiplying monomials situation, all I'm doing is multiplying 5 times x squared times 3 times x to the 6th. So I'm going to write it all out once. And when we write it all out like this, usually we're looking for a shortcut. You know, we're going to write everything out and see if we can't find a shortcut to use from now on. So I wrote this out. 5x squared is 5 times x times x. And then 3x to the power of 6 is 3 times x, 6 different x's. And because multiplication is very friendly, it's fancy words, commutative and associative. I can do it in any order I want. So I changed the order of the multiplication. I put the 5 by the 3, and I put all the x's beside each other. And if I simplify that, 5 times 3 is 15, and I count up the x's. There's 8 of them. I get x to the power of 8. Okay, fine. But do you see a shortcut? That's what we're really after here. 5 and 3 became 15. Yeah, we just multiply the coefficients. So when we're multiplying monomials, we can just multiply the coefficients. That's the easy part, I think. And then what did we do here with the x's? We added exponents when bases are the same. So I just want to highlight that because there's an important little detail here. We only add the bases when only add the exponents when the bases are the same. So all those exponent laws came from the base being the same. So let me just highlight that. When the bases are the same. We need the bases to be the same for this to work. If one of the bases was x and the other base was y or something like that, well, you couldn't add the exponents because they're not the same base. Those exponent laws came from being the same base. Okay? A couple of examples of that. Old practice it's supposed to be, but it's sort of a weird, difficult thing, so we want to make sure we have it down pat here. Okay, so 7x squared times 9x to the power of 4. Multiply the coefficients. I get 63, and add the exponents of same bases. So x squared and x to the 4th, I can add those bases. Now, if you're a little confused and you're like, well, why didn't you distribute it? That's an important little detail in all this. What was the difference up here? Was the addition in there. When it's addition in there, we do distribution. When it's multiplication in there, we don't do distribution. So yeah, maybe that's one detail. That's the one thing you're going to have to watch for in all this. This all seems pretty straightforward. Nice, simple rules. The rules themselves are simple, but when to use them is an important little detail here is distribution. When we're multiplying a constant by a polynomial so that there's multiple terms in there. This new rule, actually it's an old rule, is for multiplying monomials when there's only the one term in the brackets, okay? So here, multiplying monomials. Multiply the coefficients, negative 36, and add the exponents of same basis. Those are both y's, so I can add the basis. Last one of these type of examples. Multiply the coefficients and add the exponents of same basis. So I got x squared and x cubed. I can add those exponents. I got y to the power 4 and y to the power 9. So I add the exponents of those bases. All right, so important sheet there, or important couple of sheets there. Really, you may want to go back now and print these sheets out carefully and really write down all the details there because it might be easy to get confused between those two types of examples. Okay, here we go. Let's tie it all together. 4 final examples to tie it all together. This first example has 5x squared in front of a polynomial. There's multiple terms in there. They're adding in, there's an addition in there. And when there's addition or subtraction in there, that's when we do the distribution. So we multiply by each term in the brackets. Now, when I go to multiply each term in the brackets, that's when I'm multiplying monomials, and I go back to my multiply the coefficients, add the exponents. And then I do it again. Multiply the coefficients, add the exponents. So I've done it twice. If that's a little confusing, don't panic. I'm going to do that all again 3 more times. But I'm going to do it in a slightly different order this time. That might make a little more sense. I'm going to slow it down. I'm going to draw with the arrow. I'm going to say, okay, this term by this term. Multiply the coefficients, add the exponents. You see how doing each multiplying as I draw the arrow helps to simplify all my thinking. Do it again. Multiply the coefficients, negative 7 and negative 3 is 21. Add the exponents. And the last one, multiply the coefficients. And there's nothing to add here, so I still just have my x to the 8th in the first bracket. Okay, if that's confusing, that's okay. We're going to go and do 2 more of them. And then if it's still confusing, you just rewind the video and watch it again. A negative out front here. That's weird. So we think of that as negative 1 out front. That's what we should think, is that's what we're talking about here is negative 1. So I'm multiplying negative 1 by each of these things in the brackets. Just a special case there. I want to do one like that because that comes up and it's actually pretty simple to do, but it's weird looking because it doesn't have a number out front, and the number we're talking about when we don't see a number there, the number we're talking about is a 1. Yeah, we're talking about one of those. Okay, last one. I'll do it really slow to go through all the pieces. It's going to be distribution because there's adding and subtracting in here. There's polynomial in there. So I know I'm going to multiply, and I'm going to draw the first arrow here. I'm going to multiply each term in the brackets by what's out front. When I do that, I multiply the coefficients and add the exponents. Okay, and if that is confusing what I did there, go back to these examples. Rewatch these multiplying examples to make sure you understand the multiplying the coefficients, add the exponents. Okay, you see how I drew that arrow and I went and did something else. And because I only drew the first arrow, I'm not distracted. I can come back and go, oh, now I do the next one. Multiply the coefficients, 3 times 2 is 6. Add the exponents. Okay, those x's both have exponent 1, so I'm adding the exponent to get x squared. And then y cubed, I'm adding 2 and 1. See, these are little 1 exponents and all those. Last one, draw the last arrow. Multiply the coefficients, negative 9. Add exponents of same basis. Nothing to add with the x, but y squared and y gives y cubed because that's like a little 1 out there. Okay, so that's distributive property part 1. Really important now, go and try that homework for distributive property part 1. Don't try and move on to part 2 just yet. Try all that homework until you're like, okay, I got the gist of it. Because part 2 just takes it up one more little notch from there. Okay? Try out that homework. Check out, there's textbook examples as well right before the homework if you need to see a few more examples before you get rolling. Besides that, I'll see you in Distributive Property Part 2. Have a great day.